Okay, today we're talking about Pythagorean theorem. Maybe we've seen this in the past. It has to do with finding the legs of legs and hypotenuse of a right triangle. So we'll start with a right triangle. We know it's right because it's marked like that. We know that one of the sides is A, one is B, and the hypotenuse, or the longest side of the triangle, is always going to be that C value. And this really smart guy, Pythagoras, ancient Greek, came up with a way to find the sides. And he said if a squared plus b squared will give me c squared. Okay? So there's a couple triangles this always works for. And when we get those triangles that always have the combination that works, we call those Pythagorean triples. So we'll explore a few of those. So let's say I have a side of 3 and a side of 4, and I want to find out what this third side is. Well, first thing I'm going to do is write my formula, a squared plus b squared equals c squared. It doesn't matter which side I plug in first. I'll do 3 squared plus 4 squared equals c squared. We know 3 squared is 9. We know 4 squared is 16. When I add those two together, I get 25 equals c squared. Now I'm not done because I really want c by itself. So I'm going to take the square root of both sides. When I take the square root of c squared, I get c. The square root of 25, I get 5. So that would be my c value. 3, 4, 5 is a Pythagorean triple that will always work. Pythagorean triples, like 3, 4, 5, do not necessarily, any multiple of 3, 4, 5 will work. So if I multiplied each one of these numbers by 2, so I had like 6, 8, 10, that's a multiple of 3, 4, 5. 6, 8, 10 is it's not its own triple, but it's one of the 3, 4, 5 triples. Okay? Let me have you try this one on your own. Well, we'll pretend that's a triangle. This side is going to be 5, and this side is going to be 12. See if you can find how long C is. Good, we should have gotten that C is 13. And again, 5, 12, 13 is another Pythagorean triple. Sometimes when we're looking at a right triangle, they give us what the hypotenuse is. So let's say they say it's 25. And they'll give us one of the legs. And they want us to find the missing side. This really doesn't work so differently. I'm going to start with my formula, a squared plus b squared equals c squared. And I'm going to plug in what I know. So maybe I know b squared is 24 squared. And c squared is 25 squared. And this is where knowing your squares comes in very, very handy. So I can say a squared plus 576 is equal to 625. I subtract that 576 off both sides. These cancel, and I get a squared is equal to 49. If I square root both sides, I will get that a is equal to 7. Okay? And 7, 24, 25 is another Pythagorean triple. So let's try this on your own. I'm going to give you a triangle. I will tell you the hypotenuse in one of the sides. You tell me what the third side is. So we'll start with C is 17, this is 11, and we'll call this one B squared. Okay? So go ahead and try that one on your own. hopefully we got at least to this far where you plugged in some numbers and you got 121 plus b squared equals 289, and you subtracted 121 off both sides and you got b squared is 168. Then I take the square root of both sides and I get b is equal to the square root of 168. 168 is not something I can take the square root of and get an even number. Because remember, 169 is 13, but 12 is 144. So I can do a couple things here. And what you would like to do probably is to break down this number. So I'll say it's divisible by 8 and 24. And once I have the 8, that's 4 and 2. And that's 2 and 2. 24 is 8 and 3, 4 and 2, 2 and 2. I'm going to go through, I'm going to circle my pairs. That's a pair. That's a pair. That's a pair. And I have a lonely number. So remember, one of each pair comes out front. So one, sorry, I'm trying to make sure this is getting the right color. One of the purple 2's times one of the pink 2's times one of the orange 2's, and my lonely number stays in the radical. Then I multiply out front. 2 times 2 times 2 is 8, and my radical 3. And that would be my answer for what b is equal to. Okay? So if you get something that can't be broken or square rooted evenly, break it down, see if we can get an answer like this. Okay?